After understanding the first drawback of no precise position for hydrogen, let's move to the second one, that's the placement of the isotopes. Before that, can you tell me what isotopes are exactly? That's correct. They are atoms of the same element that have different atomic masses. And why is this so? It's because even though they have the same number of protons, the number of neutrons in each is different. So let's take carbon as an example. Three widely known carbon isotopes are carbon-12, carbon-13 and carbon-14. In all the three cases, the nucleus of the atom has 6 protons. However, the number of neutrons is 6, 7 and 8 respectively. Yes, the number is different. Thus, the chemical properties shown by each carbon atom are the same as the number of protons and electrons are the same. However, the atomic mass is different. Now you may wonder how isotopes can be a major factor for the failure of Mendeleev's table. Just think for a moment. We know that the table by Mendeleev was based on atomic masses. That means elements were arranged based on their increasing atomic masses. And isotopes, although belonging to the same element, have different atomic masses. That means they need to be placed separately in the table. For instance, just like the 3 isotopes of carbon, we also have 2 widely known isotopes of chlorine. These are Cl35 and Cl37. So where should we place all these isotopes? Should they be placed at the same position or one after the other? Since isotopes were discovered very late, Mendeleev could not predict them, and that is why he left no vacant position for them in the table. Thus, no place to fit the isotopes was another limitation of Mendeleev's periodic table. So far, we've seen 2 major limitations of Mendeleev's periodic table. Let us understand the third limitation now. That is the placement of undiscovered elements. Now you may say that Mendeleev had predicted the properties of a few undiscovered elements. He also left a few blank spaces in the table for these undiscovered elements. You're right, but his prediction was about the properties of undiscovered elements. No one, including him, could predict that how many number of elements will be discovered. But why was this a concern? We can't place the elements as and when they are discovered in the empty spaces, right? Not really. The table did have a few empty spaces, but the number of undiscovered elements was not known. So what if more elements got discovered with time compared to the blank spaces? Won't it disturb the entire table? Yes, it will. So where do we place them then? And also, how do we place them? Note that the atomic masses of previously discovered elements were not in a regularly increasing manner. Then how and where will we place the new ones? Just for the sake of understanding, let's imagine the atomic masses of 2 random elements. Element 1 has atomic mass 200, whose position comes first, while element 2 has atomic mass 196, which is placed later in the table, that is after element 1. Now in this case, if a newly discovered element, say element 3, has atomic mass of 199, where will we place it? Between the 2 elements or after the second element with atomic mass 196? We wouldn't really know as there's no pattern. Let's say I give you the following pattern. There is one empty space here, and it would be obvious that if an element with atomic mass 2 was discovered, it would be placed between 1 and 3. It's because you see a pattern here. But there was no concrete pattern in Mendeleev's table. Hence, the placement of undiscovered elements was another drawback. So the next 2 limitations that we have seen are the positioning of the isotopes and the placement of the undiscovered elements. Let's have a look at the last 2 limitations in the next video.